In this question, there are two parallel uniformly charged infinite plane sheets 1 and 2. So sheet 1 and sheet 2. Charge density of sheet 1 is plus sigma, positively charged, and minus 2 sigma for sheet 2, negatively charged. Give the magnitude and direction of net electric field at point case 1 in between the two sheets, means P, outside near the sheet 1, outside near the sheet 1 Q. I added one more point, outside near sheet 2, just for practice. This is an additional as per question we don't want to do at all. You want to find the electric field. Electric field intensity is a vector quantity. We cannot use normal addition. For vectors, if two vectors are in same direction, you have to add their magnitudes and put the same direction. If the vectors are in opposite direction, subtract, find the difference of their magnitudes, greater minus smaller, and the direction will be that of the greater one. If they are in different angles other than parallel or anti-parallel, then we have to go and use the parallelogram law of vector addition. So we'll try to find out what are the directions of electric field at P due to sheet 1 and sheet 2. Every point P, Q, R, what are the directions of field produced by positively charged sheet and negatively charged sheet. Even the magnitudes later. If you find the direction of electric field, always imagine a positive test charge at that point where you want to find the electric field P, Q, or R. And due to which sheet you are finding, if it is a positively charged sheet, check whether the test charge will move outwards, away, or towards a sheet because of the attraction or repulsion of the charge. So for example, if you want to find the direction of field at P, we are imagining a positive test charge at P. The sheet 1 is positive, the test charge also positive, so the sheet will repel the test charge downward. So E1, electric field of sheet 1 at P will be downward. Now at P we are finding the direction of electric field due to sheet 2. Sheet 2 is negative charge. The test charge is always positive. The positive test charge will be attracted by the negative plate. So it will be still downward. That means direction of electric field intensity due to sheet 1 and sheet 2 both are acting in the downward direction. Negative J cap. J cap is upward, positive y axis, negative J cap is downward. So here both vectors are in the same direction. Now go to Q. Sheet 1 is positively charged. If you leave a positively charged, positive test charge, the positive will repel it upward. So E1 will be upward. At the same point, if you neglect sheet 1 and find the effect of sheet 2, sheet 2 is negative charge, positive test charge will be attracted towards a negative sheet. So E2 will be downward. Now if you come back to the additional point R, sheet 1 is positive. If you leave a positive test charge here, the positive sheet will repel the positive charge downward. So E1 will be downward. The same positive test charge, because of sheet 2 which is negative, will be attracted upward. So this is the directions of electric field at P, Q and R because of sheet 1 and sheet 2. Now we have to find the magnitudes of E1 and E2 and use the rules what we discussed. Same direction what we'll do, opposite direction what we'll do. So we just mentioned that points as a note. Since electric field is a vector quantity, we cannot use normal addition or need to use vector addition. There are three different cases we discussed for vector addition. If both vectors are in same direction, just simply add their magnitude and use the same direction. That's applicable here. At P, both are same direction, so add E1 plus E2 and put minus j cap downward. If the vectors are in opposite direction, that's applicable at Q and R. Which is greater and which is smaller, you find out. Greater minus smaller, find the difference in magnitudes, then put the direction of the greater one. That's only applicable here because they are either parallel or anti-parallel. So if it's not, maybe a different case coming later, not in this question. If the vectors are not in different direction, not in parallel or anti-parallel directions, then use parallelogram law of vector addition. So the third case is not applicable in this particular question. There are few questions we have done using this different direction in other videos. You can check. Now we are finding the magnitudes. So the electric field intensity for a sheet, the formula is sigma by 2 epsilon. If it's air or vacuum, if no medium is given, we'll take air or vacuum, it will be sigma by 2 epsilon 0. Here there is no dependence on R. Means electric field intensity remains same at all points from the near points even to far away points. The direction, here it will be upward and the magnitude remains same. It will be downward due to sheet 1 and the magnitude remains same everywhere. Even infinity, close by points, the electric field intensity for an infinite thin sheet remains same as sigma by 2 epsilon, so there is no dependence on the distance. So no increase, no decrease with respect to distance. Now for sheet 1, just sigma is sigma only, so the formula will be sigma by 2 epsilon 0. So E1 will be sigma by 2 epsilon 0. Now for sheet 2, the only difference is the sigma becomes minus 2 sigma. For vectors, the minus quantity, the minus sign, not minus quantity, minus sign will not be used in the calculations. The minus sign is replaced by the correct direction. Even plus sign, plus normally we don't put. It's a plus what gives direction outward and minus is what gives direction towards a sheet. The positive sign and negative sign both are replaced by the correct directions. So we should not use minus 2 sigma in calculations. We just use only 2 sigma. The positive and negative signs are replaced to find the correct directions. So E2 will be, sigma will become 2 sigma. So 2 sigma by 2 epsilon 0 or sigma by epsilon 0, the magnitude. Now we will come to point number 1, which is between sheet 1 and sheet 2 at P. So you can see E1 and E2 are in same direction. So rule number 1, if both vectors are in the same direction, add their magnitudes and use the same direction. Add their magnitudes. So I told you no sign is used. So E1 is sigma by 2 epsilon 0, E2 is 2 sigma by 2 epsilon. So you can add both and put the direction downward as sheet 2 or from sheet 1 to sheet 2 or minus jkf, whatever way you can write. So it's very clear E2 is greater than E1 because this is 2 times of sigma by 2 epsilon 0, this is sigma by 2 epsilon 0. We need that greater to decide subtraction from which one to which one in the next 2 cases. So I told you P, both are in the same direction, so you can put E1 plus E2 minus j cap. And E1, E2 values are sigma by 2 epsilon 0 and 2 sigma by 2 epsilon 0. So that becomes sigma plus 2 sigma, 3 sigma by 2 epsilon 0 down minus j cap. So this is a resultant electric field intensity at P. The magnitude is 3 sigma by 2 epsilon 0. Minus j cap means from plate 1 to plate 2. So the negative sign is not used in the calculation. That negative sign and positive sign both are replaced to get the directions of the vector. Any vector, the rule is like that. The negative and positive signs indicate the direction, not only for electric field. Now for point Q. For point Q, we can see E1 and E2 are in opposite directions. So the rule is find difference of their magnitudes and use the direction of greater one. For that we need which one is greater. It's very clear E2 is greater than E1. So we subtract E2 minus E1 at Q and put the direction of E2. E2 is greater, so E2 is downward. Downward is minus j cap. So subtract greater minus smaller magnitude E2 minus E1. The direction is minus j cap. E2 is 2 sigma by 2 epsilon 0 and E1 is sigma by 2 epsilon 0. So when you subtract 2 minus 1, 1. So just sigma by 2 epsilon 0. That is along minus j cap. That's a electric field intensity magnitude sigma by 2 epsilon 0. Direction is minus j cap. That's towards sheet 1. Resultant. Now for the last point, additional point, which is not asked in the question. Here also the fields are in opposite direction. The rule is same. Greater minus smaller magnitude with the direction of the greater one. Here still E2 is greater than E1 because distance is not a factor in the field formula. So E2 minus E1. But here E2 is directed upward towards the sheet. So it will be along j cap. The direction for negative sheet is towards the plate. So below will be towards the plate means upward. Top will be towards the plate means downward. The resultant direction will be j cap. Then E2 and E1 same values, no difference. So you can subtract, it will be sigma by 2 epsilon 0 along j cap. So these are the electric field magnitude and directions at point P, Q and R. It's better to make a note like for vector quantities. The positive and negative signs are replaced by correct directions. Any vector quantity. These signs are not used in calculation. Only magnitudes are used in calculation. Whether you add or subtract, that depends upon the direction. That's the rule what we written on top already. Whether the magnitudes to be added or magnitudes to be subtracted, that depends upon these two cases. The third case is not coming in. So the vector addition concept, vector product, scalar and dot product for cross and cross, scalar product or dot product. Even the vector addition, all these three are normally very important in vectors. So you must have an idea regarding the additional vectors using different cases and even the scalar and dot, scalar and cross.